And then the next one is zero force member. So if it is a zero force member, then what are the zero force member? The criteria is at a joint. We know that we have to use fx equal to 0, and we have only two available equation. So now the condition is, if at a joint you have two forces, let's say that this is f1, this is f2. So if you use summation of, we know that this is your x, this is your y, then if you use summation of fy equal to 0, then you'll see f2y is equal to 0, and the y component, which means that f2 equal to 0. And if you take summation of fx equal to 0, then you have f2x plus f1 has to be equal to 0, because this is 0, so that means f1 is equal to 0. So what does the statement say? The statement says that if at a joint you have two non-collinear, okay, so you have a force 1 and you have its force like this, then all these forces will be equal to, all these member forces will be equal to 0 if they are non-collinear. What do you mean by non-collinear? That means they are not linear. So in this case, if you have in this joint which are linear, you have f2 here, you have f1 here, then you cannot assume that, you cannot say that f1 is equal to 0, and you cannot say that f1 f2 is equal to 0 or f1 equal to 0 unless one of them is equal to 0. So this is collinear, and this one is non-collinear. So the statement is, if there are two members and they are member forces and they are non-collinear, then you then both of those member forces is equal to 0. That is the first statement. And then the second statement is, at a joint, if you have three member forces, two are collinear and the other one is non-collinear, irrespective of what the angle looks like. For example, you have here f3, this is f1, f2. If two are collinear, these two are collinear, and one is non-collinear, which means that if this is your theta, then f3 will be equal to 0. Why? Because if I take fy is equal to 0, then I'll have f3y, and this is equal to 0, so you have f3 is equal to 0. So if there are if at a joint you have three member forces or three unknown forces, and you find that one of them is non-collinear and the other two is collinear, then your force, then the third forces or the non-collinear member forces will be equal to 0. Okay, so how do we apply this in this equation? If you look at this truss, you first have to draw all the direction of your forces of your support reaction, and then after that you apply, you say, look here, you have 1 2 3 4 5, then we cannot you we then we don't know which one will be zero force member. But if you look at this, you see that this joint has two forces, and because they have two forces and they are not collinear, then we say this equal to 0. And then we have to look here and we say that, okay, this is 0, so that means this and this, they are 3, but none of them are collinear, so they cannot be equal to 0. What about this? This is a 1 2 3, and that also will be non-collinear, that means they cannot be equal to 0. What about this? This, it has 1 2 3 4, so it has 4. Basically we can't say which one will be um, um, 0. And here I have this, they are collinear, and this is non-collinear, so I will say this is equal to 0. So in this whole truss, under a given load, let's say that this is the load, because you have to make sure that there's a load um, under the given load, then I will say that this in this case there are three zero force member, and because there are zero force member, that means I don't have to that means um, I don't have to solve for this member anymore because they are 0. So this is where this, sometimes if you don't identify the 0, and when you solve, you said, oh, I have here, I can, because I know the support reaction and I know that there are 3, I can cut the section. You say that cut the section and find the member forces, and then you find the member forces. Let's say you find that this under this P is equal to, let's say, 100 kilonewton, and you find that this member forces will take 50 kilonewton. And then when you cut the section, and then when you because you already know the forces, and then you're trying to and then you pick up that joint, and then you draw all the free body diagram of that joint, and then you realize that this in your next equation this become like 30. Like, wait a minute, from cutting the section I get 50, from using method of join I get 30. This doesn't make sense. Why do we have two number for the same member? Is because you didn't identify that this member is a zero force member. So which is why it's very important when you analyze the truss to identify the zero force member before you proceed with analysis. Okay.